Hopefully everybody had time to take a quick little break. We're going to go ahead and jump right back at it. We still have a lot of information to get through here in a short amount of time to do so. So once you finish your basic electricity and then your laundry/dishwasher assessment, you'll move on to your refrigerator portion. You'll start with your scenarios. So here are your scenarios that you may see on your refrigerator portion of your testing. So again, each bullet point is its own scenario. So you've got 5 different scenarios for your French door units. You've got a scenario for your side-by-sides and another scenario that could be basically on any of your refrigerator units. So we'll go through one of these together quickly just so you guys can kind of get an idea of what we're looking for. So one scenario I will say that you're almost guaranteed to get is that direct cool ice maker. It's not making ice scenario. I'm not going to go through that one with you today because it's a good chance many of you are already pretty familiar with the ice maker service bulletin for those ice room direct cool ice maker units. Just make sure for the assessment, you're as detailed as possible on that. You're going through all the different steps, from thawing it out to pulling everything out to completely thawing it out to using the epoxy, the Y-clips, replacing the parts, all that good stuff. But that is in STG. There's a full service bulletin on that. So you can pop that model number in your STG and you'll find that service bulletin on direct cool ice maker not making ice. And it's very detailed step-by-step what to do. So the scenario that we will go through here is that third one, fresh food section not cooling, weak cooling. Customer hears noise that stops when doors are opened. So what are we looking for there? So again, on all scenarios, you're going to start with confirm the issue with the customer. Check STG for possible service bulletins and troubleshooting help. You get 2 points right off the bat there. For this one, you'll want to check for error codes. So you throw in diagnostic mode, check for your codes. For this particular issue, it might be pretty common for you to find 22 or 22 E or C or 25 E or C. Again, remember E and C are interchangeable. And so 22 and 25, those are fresh food fan error and fresh food defrost error. So those are pretty common error codes you'll see with this issue. So if you've got a fresh food section that's not cooling or has weak cooling and the customer hears a noise that stops when the doors are open, you're likely looking at some ice or frost build up around that fan, right? And those fan blades are hitting that ice. That's likely what you have going on there. So if that's the case, you're going to take a look inside there. You might see some ice or frost coming through the vent holes, the air holes for the evaporator cover. If it's stuck and it won't come off easily, you're going to have to take your steamer and steam that thing off. Obviously, you're going to want to put it into a forced defrost, FD, forced defrost mode, to turn that heater on in the back there and hopefully help kind of thaw that out a little bit, make it a little bit easier to get off. Steam it out, get it off. You'll want to inspect that cover, make sure it's not damaged, make sure all the ice is thawed out, check the foam gaskets around the outside, make sure they're in good shape, make sure the styrofoam is in good shape, all that good stuff, replace it if it's not. Of course, you want to check for ice buildup inside there once you get it off. Usually you're going to see it at the top of the evaporator. That's the most usual spot, right where that fan sits above. And so you're going to see that pretty often. You'll check the defrost sensor. If the defrost sensor is embedded in ice, you're going to want to replace that. If it's not, then obviously put your meter on there and make sure it's within spec. And you'll find that information in STG, of course. Check the drain pan underneath the evaporator. Make sure that that drain pan is not frozen over. If it is frozen over, you'll want to use a steamer to clear that ice out. Put your steamer down the drain for a bit to make sure that's clear, and then you can use your trombone cleaner. If hopefully you have one that come in handy, to fish down that drain and make sure it's all clear. You can also pour some hot water down that drain as well to clear it out. And then, of course, go to the back of the unit, check your drain tubes, and make sure that your drain tubes are clean. Replace them if necessary. You want to make sure that your evaporator and your drain pan are positioned correctly. If you install a leak kit, which comes with the drain tubes in the back of the unit, it also comes with some foam strips that go behind the drain pan and under the drain pan. You want to install those if they're not already there. You can always bend over the last row of fins on the evaporator as well, which will help with the heat rising, and it'll help melt everything a little bit easier. It'll also help with the dripping and things like that. So once you've finished, you completed your repair, you replaced whatever you need to replace, whether it's the evaporator cover, defrost sensor, whatever it might be. You're going to go ahead and plug everything back in, fire the unit up, make sure it's working, make sure the compressor starts running, and the unit starts to cool off, and obviously put it in a diagnostic mode to check for error codes once you finish, and then explain the repair to the customer and thank them and tell them to have a nice day. All right, so that's one of your refrigerator scenarios there. What we're looking for, make sure you jump into STG and you check all these issues out and get yourself familiar with all of these and get yourself prepared for the assessment. So once you finish your scenarios, then you'll move on to your test. So again, this is another 10-question test. So you got 10 on your basic electric. You might have two 10-question tests for laundry, one laundry and one dishwasher, but there's also a 20-question. It's the same questions, but there's also a single test where they're all combined and mixed up together, which is what I use. And then you'll have your refrigerator test, which again is 10 questions. So here are some possible questions you'll get on this test. What condition is represented in the below diagram of a refrigerator sealed system? So for this one, really all you need to focus on is the compressor and the evaporator. You got a running compressor. It says running there in the box. And then it says at the bottom there, evaporator frosted from top to bottom. So if you have a good frost pattern and you have a running compressor, then you've got normal operations. So C is what we're looking for there, normal operation. Customer's refrigerator is no longer cooling. The inverter board indicator light is blinking 4 times repeatedly. What does this mean? So you got a model number there that you can reference. You can also use that model number that we had earlier during the scenario portion there, the RF28JBED will also work. If you're looking in this model here, RF28JBED, it'll be under the fast track setting all the way at the bottom. If you're looking in this model here on STG, I believe this one is in a weird spot. Usually they're in the fast track. The blink codes are almost always in the fast track towards the bottom. This one, I think it's under top solution weak cooling, if I remember right. It's in that section of STG, but usually it's in the fast track. So go ahead and do some homework on this one. Find those LED blinking frequency codes and see what 4 blinks is going to indicate there. So the condenser fan is running. The feedback line will measure approximately what voltage. So your feedback line, you got 3 lines going to your fans. You can kind of see it there, black, red, and white. It's kind of hard to see there, but you've got 3 wires. They may not be those colors necessarily, but you always have 3 wires to all of our fans. And one wire is your hot or your power going in. The other wire is your neutral or your power coming out. And the third wire is the feedback line, which is a generated voltage by the fan when it spins. So it's like a little mini generator. Generates a tiny little bit of electricity, and we send that electricity back to the board, and that's 2.5 volts DC. 2.5 volts DC, or B in this case, is what we're looking for here. And the purpose of that is just to allow the board to know that that fan is actually spinning, right? We could send power to the fan, and that power can go through and back through the neutral, and that's fine. But that's not going to tell the board that the fan's actually spinning, right? Because that fan might be stuck. It might have a mouse stuck in there or something. So it's not actually spinning, even though power is going through it. So we use that feedback line to tell the board that the fan is actually spinning. So what is the purpose of a TDM valve on a 2016 or newer 4-door flex refrigerator? So for this particular question, if you look at the picture, you'll notice that there's one copper line going in on the left side and 3 copper lines coming out on the right side. So this is what we call a 4-way TDM valve, or a 4-way step valve, sometimes it's called. So you've got 1 line coming in and 3 more lines coming out. So if you've got 3 lines coming out, you know that it's going to 3 different sections in that refrigerator, right? And in the answers here, you've only got one answer that has 3 different sections for those 3 lines to go to, and that's B, right? So you're going to direct refrigerant flow from that TDM valve to the fresh food section, the freezer section, and or the convertible section. So B is what we're looking for there. What happens if a Samsung French door refrigerator is stuck in demo mode or left in demo mode? This one, you don't want to overthink this one. It still surprises me that there's a lot of technicians that get this one wrong. But you can get a clue by looking at the display, right? If you read that as a word, okay, don't look at it as 0FF. Read it as a word, right? It says off. You see that? It says off. And that's because it's off. It's not going to cool. There's no cooling in all sections if it's in demo mode. So C is what we're looking for here. And this is important to know because if it is in demo mode, you're going to want to be able to recognize that when you look at the display right away, because the customer may not know, and they may have accidentally stuck it in demo mode, may have hit the right buttons by accident. They may have gotten the unit delivered to their house, and it was in that because it was a display, floor model, and it was never taken out of demo mode. So it's handy to know because you'll need to be able to take it out of that for the customer, which will be an STG if you need to know. All right. What is not a condition that must be met for a side-by-side refrigerator to produce ice? So don't overthink this one. Again, this is another question that surprises me that some techs get this incorrect. Don't overthink this one. Are you going to make ice if the ice bucket is full? Of course not, right? If that ice bucket is full, it's going to stop making ice. It doesn't need to make any more. So obviously the ice bucket being full, C, is not going to be a condition in order for that side-by-side to make ice, because it's not going to make ice if it's full. All right, what is the absolute minimum water pressure, PSI, that should be supplied to a refrigerator? So what are we looking for here? Do you guys know the answer to this? What's the minimum recommended water pressure for a refrigerator, specifically for Samsung, but this is pretty universal across all brands? What's the minimum water pressure? Anybody have any idea? What are we looking for here? Yep, Zhongli, that's correct. You're looking for 20 PSI. So 20 PSI is your minimum. If you do a Google search on this, you'll find that most recommend 20. You might see 40, or you might see 20 to 40 as a range if you Google it. But Samsung recommends 20 at the minimum. So what's the purpose of a defrost sensor? I'll let you guys do a little self-learning for this one as well. So go ahead and check it out in STG, Google it. What is the purpose of a defrost sensor in a French door refrigerator? What does it do? How does it work? What is it measuring? What is it telling the board to do? So go ahead and do a little homework on this one and find that answer on your own. All right, when the refrigerator sensor's temperature increases, what happens to the resistance and the voltage? So I'll give you guys a hint on this one. That sensor is going to move opposite of the temperature. So it's going to go in the opposite direction of the temperature. So for this one, what do you guys think? So that sensor is going to move opposite of the temp. The reading is going to go opposite of the temp. So as that temperature increases, that resistance and that voltage is going to decrease, right? It's going to go down. This is unlike our ovens. If you've worked on our ovens, you may have noticed that that's actually different on our ovens. On our ovens, the temp sensor on the oven is going to follow the temperature. So as the temperature goes up, it will go up, the reading will go up. As the temperature goes down, the reading will go down on your meter. So it's going to move along with it on our ovens, but on our refrigerators, it's going to move opposite of it. So as that temperature increases, that resistance and voltage is going to go down. All right, the thermal fuse on a refrigerator defrost system is resettable, the same as a bimetal. What do you guys think? Is that thermal fuse on a refrigerator resettable, just like the bimetal? No, it's not. That's right. Yeah, it's not resettable. It's a fuse, right? And like any other fuse, you can probably think of like your fuses in your car. You might have to change. You've got fuses in your microwave, right? At your filter board, a couple fuses there. Those are not resettable. Once they blow, they're no good. You got to replace. So same thing in this on your defrost system. We'll do this from time to time. It's not super common just because that defrost sensor and that bimetal both have to fail in order to get to that fuse and to pop that fuse, right? So this is really your kind of third line of defense, just to make sure that unit doesn't overheat. And but when that thermal fuse pops, that's it. You got to replace it. All right, so that's your refrigerator portion of the assessment. Those are your scenarios and your example test questions. And then your final and last piece to your full assessment will be your cooking. Of course, you may also do TVs, but we're not doing TVs for the training here. So this is just your HA stuff. For TV training, you're going to have to go and take some online courses and things like that. We don't have a live TV training yet. We're kind of working on that. So if you are interested in live TV training, we are going to be starting that up pretty soon here towards the end of the month. We're going to be giving some new training sessions, 1-hour training sessions, including TVs. But for this training, we're only going through HA products. And so the last portion of your assessment for HA is going to be your cooking assessment. So these are some sample scenarios. These are all the possible scenarios you may be asked about during your assessment. I'm not telling you that this is everything. Again, as same with all the rest of the stuff that we've gone through here today. You might see something that you haven't seen today, so don't think that this is everything, but I will tell you that it's most of all of it. But you may see something different that you didn't go through here today. So just the main thing is take good notes and get yourself familiar with STG, especially because that's really going to help you on this assessment. So these are your sample cooking scenarios. You've got 3 for electric ranges, 3 different scenarios for gas ranges, and 3 different scenarios for microwaves. So we'll go through a couple of these here. We got, I think, some time to go through, maybe 2. So we'll do a range. We'll go through that electric range. Hot surface indicator light does not turn off. It stays on all the time. If you have STG in front of you, if you have your phone with you and you're not on this on your phone, which you might be, but if you're on a computer and you're able to, go ahead and pop that in STG and pull that up if you can. If you can't, that's okay, no worries. But pop that first model number, that FE710 DRS XAA. And when you do that, you'll come to that first home screen with a picture of the range on there, and you'll click on top solution. Or I'm sorry, you'll click on symptoms first, and then you'll click on top solution. And then you'll see like maybe 4 or 5 top solutions down. You'll see it'll say hot surface indicator light. And you'll click on that one, and that'll give you all the information you need on that hot surface indicator light issue. And we'll go ahead and walk through what we're looking for on that one now. So hot surface indicator light does not go out. Why would it not go out? What are we looking for? So the first thing, again, on every scenario, you're going to confirm the issue with the customer, right? Make sure that the information on your ticket is correct. You're going to check STG for service bulletins and troubleshooting help. STG will have exactly what you need to check for this issue in there. So you can pull that up on STG. And the first thing the trainer may ask you is, why is that light? What does that light do? What's the purpose of it? What is the purpose of the hot surface indicator light? So that hot surface indicator light, that comes on when that element gets hot, right? And it's kind of like a safety. So, hey, letting the customer know your surface on your cooktop is hot. Don't touch it because you're going to get burned. So that's what that hot surface indicator light does. That's the purpose of it. So why would it be staying on all the time, even when the unit's not being used? So one of the reasons, and the most common reason, is the terminals, the contact at your element is stuck closed. And those terminals that we're looking for is 1B and 2B. 1B and 2B. And I'll show you a pictured example of what I'm talking about here. Come on. So these are your burners here for your electric units. You got a single burner and a dual burner example there. You might also have a triple burner as well. But they're all set up pretty similar. You can see you've got 4 possible wire harness connections here. You got 1B, 2B, 2A, and A. On your dual burner, you've got 1B, 2B, 2A, A, and B. And then you've got A, B, and C. Might be a third one there on your triple burner terminals. But it's always going to be 1B and 2B are going to be your 2 spots that you're going to measure for on any of the elements. So no matter how the element is set up, it'll always be 1B, 2B, and 1B, 2B will always be those 2 end terminals there. So at the very end of your terminal block there, you'll have 2B on one side and 1B on the other. It'll always be those 2 N1s on any of your burners. And you're going to measure across those 2, and you're looking for infinite or open. You want those to be open when that unit is not, when the burner is not on, and when it's cool, when it's room temp. That 1B and 2B, that should be open. You should read open on your meter. If you're reading a resistance, that means that those contacts are closed. Or if you're getting continuity, I should say, that means those contacts are closed and that element is either hot or they're stuck closed, and you've got to replace that entire element. So this whole element has to be replaced. That terminal block and thermocouple, which you can't see in the picture there. But in the middle of that terminal block, there's a rod that goes from there all the way through to the middle of the burner itself, and that's what measures the temperature, sends it back to those contacts. And so once that element heats up to a certain temp, which I think is somewhere around maybe 110, 120 degrees, somewhere in that area. Don't quote me on that. I don't remember exactly, but once it gets to a certain temp, those contacts should close. When it cools down again, those contacts will open up. So if they get stuck closed again, you'll have to replace this whole assembly in order to fix that issue. That most of the time, 99% of the time, when you have this issue where that hot light is staying on, it's going to be because these are closed, stuck, and you got to replace that element. Okay. A couple other places you may want to check as well, and this will be in STG, is you're going to want to check that hot surface lamp itself. Make sure that the lamp itself is not shorted. You're going to want to check the wire harness and make sure the wire harness is good as well. All right. So then you're going to go ahead and do your repair. Replace, say you're replacing the element, you'll go ahead and replace the element. You'll test the unit out at the very end, right? So it's the last thing you're going to do is test it. You'll turn it on, let it heat up, make sure that light comes on, turn it off, let it cool down, and make sure that light comes back off, and then explain the repair to the customer and thank them. All right, and that's your hot surface light indicator scenario. Another scenario you may get is these microwave scenarios. I'll tell you too, another common one. I'm not going to go through it with you, but another common one is that no ignition on one burner. I like to use that one pretty often because that's definitely something you'll run into. So pay some good attention to that one. Check it out in STG. No ignition on one burner. One thing I will tell you on that one for gas ranges, no ignition on one burner. One thing that you can do, if you're looking at that unit, one of your burners isn't lighting, and the other burners are lighting. If you turn the knob on so that you turn it to light, all the burners should spark, right? Whenever you turn any one of the burners on for your gas units, they should all spark. When you have it on light. So if you turn it on light and they all spark except for the one that's not working, is not sparking, one quick and easy way you can test that is to take the wires at the spark module and switch them. So you can take, so in other words, if you have one wire that's working, you have one igniter that's working, one igniter that's not. You follow those wires down to the spark module, and you can take those two and swap them. And that's one easy way to test. Is it the igniter itself that's not working, or is the spark module not sending the correct voltage? Right. So if that same igniter that's not working is now sparking, when you switch them, then you know it's the spark module, right? If that same igniter that wasn't sparking and wasn't working is still not sparking when you switch the wires, then you know it's the igniter itself. So just a quick tip there on how you can check that. So we'll take a look at one of the microwave scenarios. One pretty common one that we'll use is this microwave goes dead while cooking, comes back on hours later, and the clock is reset. You'll see that quite often in the field. So the unit goes dead while cooking and comes back on hours later. What could cause that? What would we be looking at there for that issue? So there's a couple possibilities. One very common possibility for that is going to be one of your TCOs is tripping and then cooling down and popping back into place, right? So again, start out with confirming the issue with the customer as usual, checking STG for service bulletins and testing procedures. All right. And then next thing you'll want to do is just examine all your wire connections. Okay, pop the cover, pop the control panel cover off. Take a look inside there. Just give it a good physical inspection. Look for burn marks, things like that. Check your TCOs, your bottom, your hood TCO at the bottom there. Make sure those connections are all good. Because it could be just a loose connection on one of the TCOs, and sometimes it's making contact, sometimes it's not. Things of that nature. Check for burn marks, check for things like that. Check your filter board, check your house outlet, of course, make sure the power is correct. Obviously, the power is probably good if the unit is working. But check. You want to check and make sure. Check their breaker box. Make sure that the breaker box is rated correctly. Make sure the amperage is high enough for that microwave. So you want to check that. Make sure that that's okay. That it's not their breaker that's popping, although it's unlikely if it's coming back on by itself. But you still want to check it to make sure. Finally, you want to take a look inside there and look at your magnetron. Make sure that the fan that cools all those components off is working. So there's a little fan in there behind your control panel. Make sure that fan is working. There is a service bulletin on some of our units for that, where the fan is actually tilted because the housing is bent and it's not cooling the magnetron correctly. The airflow is not flowing through there correctly, and that's causing that magnetron to overheat. And that's most likely what you're going to see in this scenario, is that your magnetron is overheating and it's getting really, really hot, and it's popping that TCO on that mag and causing that unit to shut down, right? That magnetron TCO is resettable inside that unit. So once it cools down, I believe it's around 140 degrees where it'll pop, and then once it cools back down to below that 140 mark, it'll kick back in, and the power will go back to the unit again. So that's pretty common. Generally in those situations, if it's not the fan itself that's causing the issue, or the fan is not running correctly, then it's just going to be the magnetron itself. It's not working correctly, and you'll want to replace that along with the TCO as well. It could just be the TCO itself. Sometimes they get weak. Or again, could be a wire harness issue as well. So once you figure all that out, you'll want to, again, test the unit, explain the repair to the customer, and let them know to have a nice day. One more outside of the box thing that you could also mention and get extra points for is you'll want to check for your over-the-range microwaves. You'll want to check the exhaust fan. Make sure that is facing the correct direction. So that exhaust fan for that microwave, you can flip it around in different directions depending on the installation of the unit, right? For some homes, there's a vent behind that microwave that leads outside the home. You want to make sure that fan is pointing in the correct direction. The vent could either be coming down on top of the microwave in the back, or it could be coming out. It could be connected to the back of the unit, and you want that fan blade to be pointing in the correct direction. Or if there is not a vent that leads outside, you want that fan spun in the correct direction so that the air is pulled through the bottom of the microwave and pushed back out the front of the microwave, so it kind of circulates the air through there. If that fan is the incorrect direction, it's not going to be circulating the air through there, and when they're cooking on the cooktop and using the microwave at the same time, it's just going to get way too hot without that fan running, and that could also overheat the unit and possibly trip that hood TCO, because there's a TCO on the bottom there that'll overheat from possibly getting too hot underneath there, especially if they're using 2 or even 3 burners at the same time. It's going to get really hot underneath there, so you want to make sure that fan is working correctly. And even if the fan is working, they may just be cooking some really high temperature stuff on that stovetop, and it's just too much for the microwave. So yeah, and then again, like I said, last thing, test it, explain the repair, and then thank the customer. So that's your microwave scenario there. So once you get through your scenarios, then you move on to the test. Okay, so questions for your cooking test. So we're running a little short on time, so we're going to kind of fly through this a little bit here. So microwave high voltage system consists of what components? So your high voltage system, or your high side, you'll often hear older, more seasoned veteran techs will oftentimes call this the high side. And this is your capacitor, your diode, your transformer, and your magnetron, or your high side, or your high voltage parts. All right. When checking the resistance reading of a good oven temperature sensor, what are you going to find? So we talked about this earlier, right? How the refrigerator temp sensors move opposite of the temperature. And in our ovens, the temp sensors move along with the temperature. So as the temperature increases, the resistance will also increase, right? So C is what we're looking for on this one. As the resistance increases, as the temperature increases, right? Resistance increases when temperature increases. On an electric range cooktop, what could be the reason for a hot surface indicator light to stay on all the time? So we went over the scenario for this. So you guys should all know the answer to this now, right? It's 1B and 2B are stuck closed. C. 1B, 2B are stuck closed. When checking oven temperatures, what type of testing device should be used? So we're looking for B, electronic thermometer or multimeter with thermocouple lead. B is going to be your most accurate and efficient way of checking temperatures. You can obviously use those other things, but your coil oven thermometer type that you'd buy at a store, a customer might have inside there, you see in the bottom picture there, that's going to be super accurate, but it's going to take a long time to get to that accuracy point because they kind of read slower. It takes a while for them to get there, so it might not catch up quick enough. Your laser thermometer, your laser gun, obviously will work too, but that's taking surface temperature, not air temperature, and we really want to measure the air temperature inside there. So B is what we're looking for on this one. If 120 volts AC is present at a microwave oven HV high voltage transformer, what is the possibility? What is the possible reason for no cooking? So if you've got 120 at your HVT or your high voltage transformer, and the unit is not heating, it's not cooking, what could be the reason? Well, could it be the diode has failed? Sure. Could it be the capacitor has failed? Yep, could be that. What about that magnetron? It definitely could be that. That's very likely. So it could be any one of these, right? Any one of these components has failed. D is what we're looking for there. The purpose of a microwave oven high voltage transformer, what does it do? So the high voltage transformer oven, a microwave oven, is a step up. So it's going to take low voltage and convert it to high voltage. So B. B is what we're looking for there. Which of the following TCOs in a microwave is resettable? So we talked about this, right? There's two of them inside the microwave, but only one of them is in your answers here, and that's the magnetron TCO, C. C is what we're looking for. There's also a hood TCO. A hood TCO, which is also resettable, but that, of course, is not an answer here in this question. So magnetron TCO is what we're looking for in this case. When checking a microwave diode using a multimeter and a 9-volt battery, what are you going to find? Well, you should only read voltage in one direction if you're doing this test. You should only read voltage in one direction for this test. All right. You can also just do a resistance reading or a continuity reading, and you should only get continuity or resistance in one direction as well. So if you don't have a 9-volt battery, don't sweat it. You can just take a resistance reading, and you'll get the same, essentially the same results. What is the resistance of an oven sensor at room temp? So this one I'll let you guys do a little homework on your own. Take a look in STG. You'll find oven sensor charts in STG for sure, which will give you the resistance at different temperatures. And you should find one that's close to 70 degrees Fahrenheit so you can get the approximate answer here. So go ahead and research that on your own. On a single wall oven, what happens if the main TCO is open? So what happens when the main TCO on a wall oven is open, that unit is not going to work. It's going to be completely dead. So all functions will not work. All right, and that is your assessments, and that is your training. That is everything I have for you. So those are all of your different scenarios and your different tests and test questions. Again, don't be surprised if you do see something you didn't necessarily see in the training today, but for the most part, any test questions or scenarios that you're given, you should, for the most part, have seen today during this training, but you may see something that wasn't in this training. Just FYI, it's only 2 hours and we just don't have time to go through absolutely everything. So we just picked out a lot of the most common stuff to go through here with the training. All right, make sure when you have a chance you go through STG on your own time and get yourself familiar with all those scenarios that I showed you guys today. Getting yourself prepared by looking through those scenarios in STG will also help you prepare for the test, because a lot of the test questions were born out of those scenarios or vice versa. So they're interlocked in a lot of ways. So that'll be good studying for you to go through STG. So the last thing I want to do with you guys is make sure that everybody has information on registering for SPSN. SPSN is our video platform. So if you go on the web, you can watch these on a computer, on your phone, on your tablet. It's not an app. It's just a website. And you're going to go to that URL or that website there that you see. Support US, Samsung.com training, all that good stuff right there. You can pop that into your browser. I'm not going to walk all you guys through this now because we just don't have time. But I'll show you a few snippets of how you do this really quickly. So go ahead and take a picture of the screen now if you haven't done so already. I'll leave this up for a second here. You can also go ahead and scan that barcode right now if you have a barcode reader. And that'll pull that website up for you. Once you get that pulled up, you'll see that welcome screen, and you're going to go ahead and click on register. So you'll click on register. Once you go to that website there at the top, you'll click on register. After you register, just to let you know, under partner profile, for the first one there, group, you're going to select in-home. Okay, all the rest of this is pretty self-explanatory, but that one, just to make sure you select the right thing, you're going to select in-home for group. All right, and then you'll put your company name, your job title. You can just put technician. Account number will be your company account number. So you'll have to get that from your manager if you don't have it. I believe it's the same account number you use when you call tech support. So if you know what that is, that main account number, that should be what your account number is. But just check with your manager and make sure you have the correct one there. And then your tech ID, of course, you'll put in there. If you don't have a tech ID, which you may not if you're an ASC, then you can just enter 0000, quadruple 0 in that tech ID spot, and that will work. Okay, that's if you're an ASC and you don't have a tech ID. If you do have a tech ID, please make sure you put your tech ID in there. So once you get that filled out, then you will fill out the rest of it. So your core profile with your email, you'll have to create your own password. There is some rules to that, so I think you've got to do 8 characters. I believe 1 capital letter, 1 lowercase letter, 1 number, at least, and 1 special character like the @ symbol or something like that for the password. You put your personal profile, so your first name, last name. The demographic profile at the bottom you don't have to fill out. That's not required. So unless, of course, you want to, it's up to you. And then you'll hit submit. Once you hit submit, it'll tell you that you successfully registered. Once you've registered, you have to be activated. They check it periodically throughout each day. So you'll probably be activated likely within a few hours of registering, but it could take up to 24. So just make sure you're patient with that. Once they activate you, then you'll be able to go ahead and log in to SPSN, and you can watch training videos. There's tons of training videos in there, a lot of really good content. There's also live webinars that are recorded and put in there as well. So if you miss our live webinars, you can go in there and view them in SPSN. So some good training content there. The last thing I want to share with you is this page here. If you don't have STG yet on your phone, here's the information on how to get it. STG is an app, but you can also use the web to go to it as well. Same thing with Haas. Haas will only work for Android. So if you have an iPhone, if you guys use an iPhone for work purposes, you won't be able to use Haas. Just FYI, you need an Android for that. And then our Visual Pack or Visual Support, you can find in the Play Store or App Store, and you just search Visual Support for the keyword, and that'll pull that up, that little symbol there. Visual Pack, if you're unfamiliar with that, that is like a kind of like a FaceTime or like a Skype for technicians and tech support. Tech support will give you a code. You open up this app, you put the code in there, and they'll be able to use your phone to see what you're seeing. They can take screenshots of what you're seeing on your phone. So it's really helpful, especially if you have like physical damage issues that you need to report, you need to document, things like that. Or if you're just having trouble figuring an issue out and you're having a hard time explaining to them what you're looking at, you can actually show them. So it's pretty nice. Haas, if you're not familiar with that, that is our troubleshooting tool. You can connect your phone to the appliance and run tests through your phone and save the test information. You can send it to Samsung as well. So it's a pretty neat little tool. And of course, STG is our tech guide. So that's a must. You can make sure you have that on your phones. And I would definitely make sure you have that up and running for your assessment, because you'll be able to use it, like I said before, during your assessment. So make sure you have it up and ready to go. There's a helpline number there if you're having trouble logging in to your STG for some reason. Can be an issue. You can call that line there, and they can help you out as well. So take a screenshot of this if you need it. Make sure you get the stuff up on your phone and going. But that's all I have for you guys. That's all I wanted to go through. At this point, if anyone has any questions, feel free to chime in. I can stay as long as you need me to stay. If you don't have any questions, you can jump off. Thank you guys for being here. I appreciate it. As I said in the beginning, 87% of the guys that attend this training pass their assessment on the first try. So you've already given yourself an advantage right there. Like I said, get yourself into STG, get yourself familiar with all those scenarios that I gave you today, so that you're ready to go for the test. But yeah, that's all I have. Thanks guys for being here. I appreciate it. If you have any questions, let me know. Otherwise you can jump off. You guys are good to go.